In this video, we're going to look at writing expressions for area and perimeter for rectangles. Now, before we go ahead, we have to know one formula, which is for area. And the area of a rectangle is area equals length times width. Now, it doesn't matter what you say is L, so what you say the length is or what you say the width is, as long as you don't mix the two of them up. So what I'm going to do is I'm going to call the top here width and this one L. I'm then going to write the formula for area of a rectangle, so which is A equals length times width. I'm then going to do something called substitution. So all that is I've said W is x plus 5, and I've said the L is just 5. So substitution is, instead of writing the letter, I'm going to write what the actual value is. So again, writing this, A equals, now instead of L, I'm going to write 5. Put the times there, and instead of W, I'm going to say x plus 5. Okay, now what I need to do is I need to multiply this together. Now, because there are two terms for the width, I have to put a bracket around it. And this is where the previous video that I've done on expanding brackets will come in handy. So if you find this next step a bit tricky, go and check that video out here. Okay, and that will help you out. So I'm then going to write A equals 5, open bracket, x plus 5. Okay, going from the technique in the previous video, I'm going to use the arrows. So it will be 5 times x. So A equals 5x. And then I'm going to do the second term, which is 5 times plus 5. And then 5 times a plus 5 will give me plus 25. Okay, so the expression for the area of this particular rectangle, the area equals 5x plus 25. Now moving on to the perimeter. So making sure we understand what perimeter is. Perimeter is the outside of the shape, the outside distance of the shape. Okay, area for a rectangle at least is length times width. Okay, but the perimeter is the outside. So what we need to do, we need to mark a starting point. So I'm going to do so with this circle. I'm going to pretend that I'm literally walking around the shape. So I'm going to write P for perimeter. Then I'm going to start my starting point and walk around the shape. So first off, I have x plus 5. Okay, and now I've walked here. I'm then going to have to walk down here. So my next term to add is plus 5. That means I'm currently here. Okay, now I haven't written anything here yet, but this length here is the same as this one here. So this is going to be x plus 5, and whilst we're at it, this length here will be the same as this length here. So that will be 5. Okay, so the moment I'm here and I need to carry on walking until I get to my start point up here. Okay, so I then need to write x plus 5 again. That means I'm here, so the last stretch, then I've got plus 5. Now in a previous video where I've done collecting like terms, and I'll link that here, you all know how to do this next step. What we need to do is look at like terms. So that means I'm going to start off with x. That's the first term that's given to me. I'm then going to scan the expression for all other values of x. So I've got an x here and an x here. So how many x's in total? Let me just write p here. I will have 2x in total. I then scan the expression for the remaining terms, which happens to be 5. So I've got a plus 5 here, plus 5 here, plus 5 here, and a plus 5 here. So if I add all of those up, I'll get plus 20. So in terms of my expression for perimeter, the answer to that is perimeter is equal to 2x plus 20. Now, at the moment, these are expressions, so they are ready for you to say x is a particular value. So just to give you an example, if we were to say for perimeter, the value of x is 10, I would then do 2 times x, so 2 times 10, which will give me 20, then it would be 20 plus 20, which would give me a perimeter of 40. Okay, so the whole idea behind leaving x as a variable means that you can change the variable value. So you can say x is 1, x is 2, x is 100, and so on. Okay, but for now in this video we're focusing on just being able to write the expressions for them. So if I move on to question 2 now, again you can pause the video and maybe have a go yourself. If not, we can carry on working through it. So this is a rectangle again. So my formula is going to be A equals length times width. Okay. Now what I can do for this version is, rather than doing it as we're working through, I can say, right, this 2 here is the same as this 2 here, and this x minus 10 is the same as this one here. Now for the area it doesn't matter so much, but for the perimeter it will do. So I'm going to say this time, just to make it different, this is going to be L and this is going to be W. Okay, just to show you that it actually doesn't matter. So if my formula is A equals LW, I've said that L is x minus 10 and W is 2. So in brackets x minus 10 times W, which is 2. So if I rewrite that, I'm going to have A equals 2 x minus 10. Okay, and I've just moved the 2 to the other side just to make it similar to how we've expanded before. So if I just move this down, okay, so again I do my expansion, so 2 times x, which will give me A equals 2x, and then 2 times minus 10, which will give me minus 20. So in terms of my expression for area, it is A equals 2x minus 20. Now just quickly before we do the perimeter, I did say at the beginning of this question that I'll show you that it doesn't matter which is length and which is width. Now I just want to show that to you just very quickly. So what I'm going to do is I'm going to rub this L here out here and this W, and I'm going to switch them around. So this is now going to become W and this is going to become L. So if I just write area number 2, just to prove to you this is what I'll get at the end. So A equals L times W, A equals L, so now L is 2 times W, which is x minus 10. I then write A equals 2x minus 10. If I then expand this, I get 2 times x, which gives me A equals 2x, and then 2 times minus 10, which gives me minus 20. And here you can see that this here is exactly the same as this one there. Okay, so I just wanted to show you that because I did say that at the beginning and it might have confused some of you. Right, now let's get on to working out the perimeter for this one. Right, so the perimeter is, again, pick our starting point. So I'm going to just pick this starting point just for consistency. Doesn't matter where you start as long as you don't overdo or not do enough of the perimeter of the rectangle. So I'm going to start here and work my way around. So I'm going to write P for perimeter, and I'm going to write x minus 10, and that's my first length. And then at this point here, I'm then going to walk down, okay, which is then plus 2. I'm now at this point here. I'm going to carry on walking. X minus 10. I'm now at this point here on my final stretch. So my last term to add is the plus 2. Then I'm going to collect the terms. So I've got an X here. Do I have any other X's? I do. And I've just noticed a mistake that I've done. So if you look here, so I've got X minus 10, which was the first. I then got add 2, which is correct. But I didn't write plus X minus 10. Okay, so just a heads up there. I forgot to write that. Right, so let me just look at that expression again. So I've got X and then another X here. So in total, I have 2X. And then looking at all of the numbers, I've got minus 10 plus 2 and then a minus 10 plus 2. Okay, so I can do this step by step. So I can do this as a pair and this is a pair. So if I want, I can do minus 10 plus 2, which is minus 8. Again, I've got minus 10 plus 2 is minus 8. So this is kind of showing you're working here. And then one more line down, I can then simplify this. So I've still got my 2x. And then minus 8 will give me minus 16. Okay. Now this step here isn't necessary, but it's a good idea to show you're working. And if you're not sure, you can always just break it down so that you're comfortable, you know that the answer is correct. You don't want to be able to do questions like these and the last step you're kind of thinking that you're guessing. Right, so now let's move on to question 3. I'm going to say that actually what I would recommend you to do now is pause this and give this one a go. Okay, after these first two you should be able to give question 3 a go. Right, so let's look at question 3. This is going to be the length and this the width. So area equals length times width. Area equals 4, open bracket, t plus 3. I then expand. 4 times t is 4t. 4 times plus 3 is plus 12. So my expression for area for this particular rectangle is a equals 4t plus 12. Now moving on to perimeter. Just move that up. Perimeter p equals, again pick a starting point. So just to change it, we're going to start at the bottom left instead of the top left. Okay, and just quickly, t plus 3 is t plus 3 here as well, and the 4 at the top is the 4 at the bottom. So starting in the bottom left and working my way around, I will have t plus 3 plus 4 plus t plus 3 plus 4. Okay, look for my like terms, so t, p equals 2t, and then look for my other like terms, so plus 3 plus 4 plus 3 plus 4. Again, you can break this down, so 3 plus 4, so in these pairs, 3 plus 4 will give us 7, so you can write plus 7 plus 7, and then again p equals 2t, and then add these two together to give you plus 14. So my expression for perimeter for the third question is p equals 3t plus 14. So hopefully you've enjoyed this video and it's been useful. If you did, drop it a like down below. Also make sure you give a comment if you're stuck with anything on this video, or you want any particular type of video, make sure you let me know. Also subscribe, because you'll be getting notification of when I upload these videos, which is going to be on a regular basis.